वेलकम टू मैक्सवेल जीएम से चैनल आपका हार्दिक स्वागत है. Today you are going to learn distance, how to find the distance between 2 points. Distance between 2 points given 2 points P of x1, y1 and Q of x2, y2. The distance between these points is given by the formula D equals to square root of x2 minus x1 whole square plus y2 minus y1 the whole square. The distance between PQ is the distance between QP. Both are same. So that is the square root of x2 minus x1 square plus y2 minus y1 square is equal to square root of x1 minus x2 square plus y1 minus y2 the whole square. Now after this we have the distance of a point from the origin is P of x1 comma y1 from the origin 0 comma 0 is OP is given by square root of x1 square plus y1 square. After this we will learn the properties of distance. We have already seen that the distance a comma b is the distance of b comma a. For any points a comma b on the plane, what other properties we have noticed in case you have missed them. There are some distance a comma b is equal to 0 exactly when A and B denote the identical points A equal to B. Distance A comma B is greater than 0 for any two distinct points A and B. Now consider the 3 points A comma B and C. If we are given their coordinates and we find that their coordinates are the same, then we know that they are collinear and lie on a line parallel to y-axis. Similarly, if their x coordinates are the same, then we know that they are collinear and lie on a line parallel to the x-axis. But these are not the only conditions. Point 0, 0, 1, 1 and 2, 2 are collinear as well. Can you think of what relationship should exist between these coordinates for the points to be collinear? The distance formula comes to our help. Here we know that when a comma b and c are the vertices of triangle, then we get distance of AB plus distance of BC is greater than the distance of AC. When do 3 points on the plane not form a triangle, then they are collinear. When they are collinear, of course, in fact we can show that when the distance of a comma b plus the distance of b comma c, distance a comma is equal to the distance a comma c, the points a, b and c must be collinear. Similarly, when a comma b and c are the vertices of triangle, right angle triangle, where angle abc is 90 degree, we know that distance AB square plus distance BC square is equal to distance AC square. With the appropriate naming of vertices, we can also show that the converse holds whenever the equality here holds for A comma B and C. There must be the vertices of right angle triangle, and the following example illustrates how these properties of distance are useful for answering the questions about specific geometrical shape. Now in exercise 5.2, we will find the distance of the following pair of points 1, 2 and 4, 3. In the second problem 3, 4 and minus 7, 2. A, B and C, B, and last problem 3, minus 9 and minus 2, 3. Let us take the first problem 1, 2 and 4, 3. Let the point A is 1, 2 and point B is 4, 3, and the distance between them is given by the formula square root of x2 minus x1 whole square plus y2 minus y1 the whole square, and square root of x2 is 4 minus x1 is 1 the whole square plus y2 is 3 and y1 is 2 the square root of, so 4 minus 1 is 3 square plus 3 minus 2 is 1 square under the square root and 9 plus 1 3 square is 9 and 1 square is 1, so 9 plus 1 is the square root of 10 is the distance of the a comma b. In the second problem 3 comma 4 and minus 7 comma 2, let the point A is 3 comma 4 and point B is minus 7 comma 2. Then the distance formula is given square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Here we can take x1, y1 is 3 comma 4 and x2, y2 comma is minus 7 comma 2. So x2 is minus 7 and x1 is minus 3 the whole square plus y2 is 2 minus y1 is 4 the whole square. Minus 7 minus 10 both the numbers are negative, so add and put negative number negative sign. Minus 10 square plus minus 2 square under the square root. 10 square is 100 plus 2 square is 4 and the square root of 104 is the distance between these 2 points 3 comma 4 and minus 7 comma 2. The third problem is a comma b and c comma b. We are finding the distance between these 2 points. Let a comma b is x1 y1 and c comma b is x2 y2 and the distance formula is given d equals to square root of x2 minus x1 square plus y2 minus y1 square under the square root. So it is c minus a square plus b minus b square, c minus a square b minus b the whole square under the square root, c minus a the whole square plus 0 square is c minus a square. Under the square root we have square root will get cancelled and we will have c minus a units is the distance between these 2 points. Next we will find the distance between 3 comma minus 9 and minus 2 comma 3. The distance formula is given by square root of x2 minus x1 the whole square plus y2 minus y1 the whole square, which is equal to x2 is minus 2 and x1 is minus 3, x2 is minus 3, so it is minus 3 according to the formula minus 2 minus 3 the whole square plus y2 is 3 and y1 is minus 9, so it is 3 minus of minus 9 the whole square. Minus 2 minus 3 square is minus 5 square. Two negative numbers, add the numbers and put negative sign and square of that number plus 3 minus of minus 9 is 3 plus 9 the whole square. So 5 is minus 5 square is 25 and 3 plus 9 is 12. 12 square is 144. 25 plus 144 under the square root is square root of 169 is square root of 13 into 13. Therefore the distance between these two given points is 13 units. The next problem is second problem, determine whether the given set of points in each case are collinear or not. So 7 comma minus 2, 5 comma 1, 3 comma 4 is the problem given. We have to determine whether the points are collinear or not. So let point A is 7 comma minus 2, point B is 5 comma 1, point C is 3 comma 4. We will let us understand this concept by the diagram. So let us draw a line and take 3 points on it, A comma B comma C. If we have AB plus BC is equal to AC, then we can say that the given points are collinear. That means we will find the distance AB first, and distance AB is given by the formula square root of x2 minus x1 the whole square plus y2 minus y1 the whole square, and x2 is 5 comma x1 is 7, so it is 5 minus 7 whole square plus y2 is 1 and y1 is minus 2, so it is 1 minus of minus 2 the whole square. 5 minus 2 square is minus 2 square plus 1 minus of minus 2 is 1 plus 2 is 3 square. 2 square is 4 plus 3 square is 9, 4 plus 9 under the square root, and the distance is root 13 units. Second distance we will find as the distance of B and C is given by the formula x2 minus x1 the whole square plus y2 minus y1 the whole square. The points B is 5 comma 1 and C is 3 comma 4. So the distance BC is square root of 3 minus 5 the whole square plus 4 minus 1 the whole square is square root of minus 2 square plus 3 square. Minus 2 square is 4 and 3 square is 9 under the square root. Square root of 13 units is the distance of the BC, points BC. Next distance we will find AC. Distance AC, A is 7 comma minus 2 and C is 3 comma 4. Distance AC is given by the formula square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Is the square root of x2 is 3, x1 is 7, so it is 3 minus 7 the whole square plus x2 is 4 and y1 is minus 2, so minus of minus 2 is plus, so 4 plus 2 the whole square. 3 minus 7 square is minus 4 square plus y plus 2 is 6 square. So square root of 16 plus square root of 36 is square root of 52, which is a square root of 13 into 4, and 4 is the perfect square number, so 2 can be taken out. Square root of 4 is 2, so 2 is out. So AC is the distance which is 2 times square root of 13 units. Now let us verify these given points are collinear or not. So let us have AB. AB is root 13. AB plus BC is root 13 plus root 13 is 2 times root 13, which is equal to AC. Hence the points are collinear. Let us check for the second problem whether the given points are collinear or not. The 3 points are A. Let A is A comma 2, B is A comma 3 and C is A comma 0. The distance AB is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square, which is x2 is a, x1 is a, so it is a minus a square plus y2 is 3 and y1 is 2, so it is 3 minus 2 the square. A minus a is 0 plus 3 minus 2 is 1 square, so square root of 0 plus 1 is 1, square root of 1 is 1, and the distance BC is again the same formula. We will use the coordinates of B is a comma 3 and C is a comma 0, so the distance BC is square root of a minus a square plus 0 minus 3 whole square. A minus a is 0 and 0 minus 3 is 3 square, minus 3 square is square root of 3 square, which is 3, and the distance AC is distance a minus a square plus 0 minus 2 square, which is 0 plus 4, so square root of 4 is 2, is the distance AC. Now let us check for points are collinear or not. Here we will find that AB and AC are too smaller, and therefore AB plus AC is 1 plus 2 is equal to 3, which is AB. Here we found that C is between A and B. So AC plus BC will get as AB, therefore the points are collinear, we can say. Hence the points are collinear. In the next problem, so that the following points taken in order form an isosceles triangle. So let us have first problem. A is 5 comma 4, B is 2 comma 0 and C is minus 2 comma 3. Let us draw a triangle ABC and let us write the coordinates of A is 5 comma 4, B is 2 comma 3 and minus 2 comma 3. We know that in a triangle when two sides are equal we can say that the triangle is an isosceles triangle, therefore we will find the distance AB, distance BC and distance AC, and if we get two sides are equal then we can say that the given triangle or the given vertices forms the isosceles triangle. So the distance AB is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square, which is square root of 2 minus 5 the whole square plus 0 minus 4 the whole square, and 2 minus 5 is minus 3 square plus 0 minus 4 is minus 4 the whole square. 3 square is 9 and 4 square is 16 under the square root. So square root of 9 plus 16 is square root of 25 units, and square root of 25 is 5. Therefore the distance AB is 5 units. Next we will find the distance BC. Point B is 2 comma 0 and point C is minus 2 comma 3. So the distance BC is square root of minus 2 square plus 3 minus 0 square by substituting the values of x2, x1, y2, y1, and the minus 2 will become minus 4 square plus 3 square under the square root, and 4 square plus is 16, 3 square is 9, 16 plus 9 is 25 under the square root, which is equal to 5 units. Next the distance AC we will find, already we obtained the two sides are equal. In the distance AB and distance BC are both 5 units, therefore it is an isosceles triangle we can say. But anyhow we will find the distance AC also. The coordinates of A is 5 comma 4 and coordinate of C is minus 2 comma 3. So minus 2 minus 5 is square plus 3 minus 4 square under the square root. And the next step for this is minus 2 minus 5 both are negative number, add negative number and put negative sign under the square root. The minus 7 square plus minus 1 square, 7 square is 49, 1 square is 1, so square root of 49 plus 1 is square root of 50. Therefore we obtain that AB equal to BC, hence ABC is an isosceles triangle we can say. Hence ABC is an isosceles triangle. Second problem is given that coordinates of A is 6 comma minus 4, coordinates of B is minus 2 comma minus 4 and coordinates of C is 2 comma 10. So the distance AB is given by the formula square root of x2 minus x1 the whole square plus y2 minus y1 the whole square, and which is square root of minus 2 minus 6 square plus a square root of minus 4 comma 4 square, which is square root of 8 square plus minus 4 plus 4 is 0 square, which is square root of 64. Square root of 64 is 8. The distance BC is given 2 plus 2 square plus 10 plus 4 square, because by substituting the values of x2, x1, y2, y1, which is square root of 4 square plus 14 square. Square root of 4 square is 16 plus square of 14 is 196. So under the square root 16 plus 196 is square root of 212. So the square root of 212 can be written as it is, as 212 is not a perfect square. Now distance AC, we will find the distance AC here. A is minus 6 comma 4 and C is 2 comma 0, and the distance AC is 2 minus of minus 6 will become the plus 6, so it is 2 plus 6 the whole square plus 10 minus 4 square. 2 plus 6 is 8 square, plus 10 minus 4 square is 6 square. 8 square is 64, 6 square is 36. Therefore, square root of 64 plus 36 square root of 100, which is equal to 10, and all the three sides are different. Therefore, the given triangle, the vertices of triangle does not form the isosceles triangle. Hence, we have learned how to find the distance between the 2 points, how to find the collinear points, whether the given points are collinear or not, and how to decide whether the given points will form the isosceles triangle. This is how we have to solve the sum properly, and learn by practice. We have to write and see all the problems. Good luck. Thank you. Thank you for watching this video.